All right, so in this class today, we're going to talk about geometric sequences. Now, let's first look at the definition of a geometric sequence. So, a geometric sequence is a sequence in which each term can be obtained from the previous one by multiplying by the same non-zero number. We call this number the common ratio R. And a sequence is geometric if the next term divided by the current term is this common ratio R. And a geometric sequence can also be referred to as a geometric progression. That's just another way of calling it. All right, so let's get into the general term. So the general term formula, I mean. So for a geometric sequence with first term u1 and common ratio r, the general term or nth term is u of n is equal to u of 1 times r to the n minus 1 power. Okay, so this just means that, for example, the first term, u of 1, if you plug it in here, would just be u of 1 times r to the 0th power, which would be u of 1. I mean, it's not very helpful, but u of 2 would be, for example, u of 1 times r to the power of 1. So that would be u of 1 r. And then u of 3, same way, would be u of 1 r squared. And then u of 4 would be u of 1 r cubed. Okay. All right, let's take a look at the example. So in our first example, consider the sequence 8, 4, 2, 1, and a half. First, we have to show that the sequence is geometric. Now, the easiest way to do that is just to show that there's a common ratio. And we can do that by, for example, 8 divided by 4. Sorry, 4 divided by 8. That would be 1 over 2. And 2 divided by 4. So, sorry, 4 divided by 8 is the second term divided by the first term. Yeah, that's how I do this. Okay, so show that the sequence. All right, so show that the sequence is geometric. So the best way to do that, the most standard way, is to show that u2 over u1 is equal to u3 over u2. Okay, let's try and do that. So u2 over u1 is 4 over 8, so that's equal to a half, and u3 over u2 is 2 over 4, which is also equal to a half, therefore geometric. All right, let's continue. Find the general term u of n. So first we already have the common ratio, which is 1/2. So r is equal to 1/2. And now we have to find the first term, which is right here. So u1 is equal to 8. And we just plug it back into the general formula, which is right here, the general formula. U of n is equal to u of 1 times r to the n minus 1 power. U of 1 times r to the n minus 1 power, or we can write that as 8 times 1/2 to the n minus 1, and that's basically it. And we could simplify this a bit by flipping the n minus 1 around, so that'll be 2 to the power of 1 minus n, and then we can absorb the 8, since 8 is 2 to the 3. This will be equal to 2 to the 4 minus n power, just like that. So that's the nth term. Okay, hence find the 12th term as a fraction. That's very easy. 12th term is just n equal to 12. So we've already done the grunt work. So u of 12 is equal to 2 to the power of 4 minus 12, and that's just equal to 2 to the power of minus 8, which is 1 over 256. Okay, that's our first example done. And I'm just going to do a few more examples, but the fundamental principle that we need to know for this chapter is just the common ratio R, and to understand the general formula, U of n is equal to U of 1 R to the n minus 1 power. So for geometric progression. Okay, so in the next example, k minus 1, 2k, and 21 minus k are consecutive terms of a geometric sequence. Find k. All right. So remember what I wrote before, which was U of 2 over U of 1 must be equal to U of 3 over U of 2. This is true if it's a geometric sequence. And so uh, we can plug in U2, so that would be 2k over k minus 1 is equal to 21 minus k over 2k. And now we just solve for k. Multiply both sides by 2k, we get 2k squared. Multiply both sides by k minus 1, we get 21 minus k times k minus 1. And then we expand both sides. 4k squared is equal to, uh, that would be 21k minus k squared minus 21 plus k. And now we can move everything to the same side. We'll move it all to the left. 3k squared minus 22k plus 21 is equal to 0. And this can be factorized pretty quickly. 3k, oops, sorry, I made a mistake here. That should not be 3k, that should be 5k. 5k minus 7 and k minus 3 is equal to 0. Therefore, k is equal to 7 over 5 and k is equal to 3. So both of these are plausible answers. Okay. All right, I'm going to do another example. A geometric sequence has U2 is equal to minus 6 and U5 is equal to 162. Find its general term. All right. So the way to do this is to remember what we wrote above, which is that U2 is equal to U1 times R, and U5 is equal to U1 times R to the 4. And we can equate that to minus 6 and equate that to 162. And now it's just some basic simultaneous equations for these. So U5 we can put on the top divided by U2 would equal to U1 R to the 4th power over U1 R, which is equal to R cubed, because the U1s cancel out and the R cancels out with the 4. And that's equal to 162 divided by minus 6, which actually becomes minus 27. So R is minus 3. R is minus 3. Okay, and the first term we need to find. So U of 1 times R is U2. That was minus 6. So therefore, U of 1 times minus 3 is equal to minus 6. And U of 1 would equal to 2. So we have the general term now. U of n is equal to 2 times r to the power of, sorry, not r, I apologize, minus 3 to the power of n minus 1. Okay, that's the answer. Okay, we will continue with one last example. Find the first term of the sequence 6 root 2 blah blah blah, which exceeds 1,400. Okay, so u of 1 is just 6. R is clearly just root 2 because that's u is u1, that's u1 times r. And so uh u of n is just u of 1 times r to the n minus 1, which would equal to, sorry, let me do that again. U of n is equal to u of 1 times r to the power of n minus 1, which is equal to 6 times square root of 2 to the n minus 1 power. And so we can equate that to 1,400. So 6 times root 2 to the n minus 1 power is equal to 1,400. And we have to see when that's over that. So probably best to use a graphics calculator, or you can just plug and chug and just keep trying until it works. So for example, we can see when this exceeds that, and you'll find that n is equal to 17 is when this exceeds that. So u of 17 is the first term. Yeah, so because for example, u of 17 would be 1,536, and u of 16 would be, one second, 1,086. So that would not be enough. And so, yeah, yeah, and so our u of 17 is the final answer. Sorry, 1,536 is the final answer. Okay, thank you for watching.